Morning. Today I am going to solve a problem. The problem comes under the category of construction and working principle of a Carnot cycle. The problem is 1 mole of an ideal gas used as a working substance in a Carnot cycle. It operates initially at 610 degree Kelvin and 10 to the power of 6 Newton per meter square in the compression stage. The gas then expands isothermally to a pressure of 10 to the power of 5 Newton per meter square and adiabatically at 310 degree Kelvin. Determine net change in energy, amount of heat added and removed from the system and surrounding, net work done for each step. Also determine the net work and the efficiency of the cycle. Take heat capacity at constant volume Cv is equal to 20.78 joule per mole degree Kelvin. In Carnot cycle we have 4 processes. Process number 1. Process 1, that is reversible isothermal expansion. Reversible isothermal expansion process. Isothermal means temperature is constant, hence changes in temperature is equal to 0. When temperature is constant, internal energy of the system is constant, hence changes in internal energy is equal to 0. This information provides the finite change in energy of the system, then E1 is equal to 0. Clear? Okay. What is the first law of thermodynamics? Changes in internal energy is equal to heat content minus amount of work done. Since changes in internal energy is equal to 0, this dq is equal to dw is equal to p into dv, or QH is equal to W1 to 2 is equal to N R T ln P1 by P2. This is the equation to estimate amount of heat added to the system from source or amount of work done by the system. So QH is equal to W1 to 2 is equal to 1 mole into 8.314 joule per mole degree Kelvin into temperature for a process 1 to 2, T1 is equal to T2 is equal to TH, that is equal to 610 degree Kelvin. This is given in your question paper. Initial pressure P1 is equal to 10 to the power of 6 Newton per meter square, and final pressure P2 is equal to 10 to the power of 5. This is 10 to the power of 6, this is 10 to the power of 5 Newton per meter square. There is no information regarding volume, it doesn't matter. Now I am going to substitute this information here into ln P1, that means 10 to the power of 5 divided 10 to the power of 6 divided by P2 10 to the power of 5. What's the answer? The answer becomes 11,677.6 joules. Mole gets cancelled, Kelvin gets cancelled. Temperature into temperature 610 degree Kelvin, or T 610 degree Kelvin into ln 10 to the power of 6 divided by 10 to the power of 5. So Kelvin gets cancelled. The answer becomes 11,677.6 joules. Clear? Q is equal to, that means this much amount of heat gets transferred from source to hot thermal reservoir to system in order to maintain the isothermal condition. This is the amount of heat added to the system in order to maintain isothermal condition for expansion process. Or W12, this is amount of work done by the system for expansion work. Amount of heat added, amount of work done by the system for expansion process. This is stage 1. So now I am going to write for a process 1 to 2 reversible isothermal expansion, del E1 is equal to 0, QH is equal to W1 to 2 is equal to 11,676.6 joules. This is stage 1 or process 1. Next, process 2. Process 2, that means reversible adiabatic expansion. Reversible adiabatic expansion process. Adiabatic means Q is equal to 0, Q is equal to constant and changes in heat content is equal to 0. Clear? This is the process 2 to 3. Process 2 to 3. T2 is equal to 610 degree Kelvin and T3 is equal to 310 degree Kelvin. P2 is equal to 10 to the power of 5 Newton per meter square and P3 is unknown. Now I am going to establish the P3 value. The temperature and pressure relationship in the adiabatic process is T to the power gamma into P power 1 minus gamma is equal to constant. Using this relationship, I am able to find out the P3 value. So P3 is equal to P2 into T3 divided by P2 power gamma divided by gamma minus 1. So P3 is equal to P2 10 to the power of 5 Newton per meter square into T3 310 degree Kelvin divided by 600 degree Kelvin power gamma 1.4 divided by 1.4 minus 1. The answer becomes 9,356.6 Newton per meter square. So the final pressure P3 was established using temperature pressure relationship 9,356.6 Newton per meter square. Okay, the first law of thermodynamics for non-flow process, du is equal to dq minus dw. dq changes in heat content is equal to 0 minus dw is equal to du or dw is equal to minus cv into dt. On differentiation, minus cv into final temperature to initial temperature, that means T for T3 minus T2. Hence I am going to write like this, T2 minus T3. So Cv 20.78 joule per mole degree Kelvin into T2 value 610 minus 310. Clear? This is Kelvin. Kelvin gets cancelled. The remaining answer becomes 6,234 joule per mole. For 1 mole of the working substance, mole gets cancelled. The answer becomes 6,234 joules. Clear? This is dW, that is equal to R du minus du. dW is equal to, that means this is the amount of work done by the system for adiabatic expansion. This is the amount of work done by the system for adiabatic expansion. R minus dW is equal to 6,234 joules. R changes in internal energy is equal to minus of 6,234 joules. This means for adiabatic expansion, this much amount of energy is utilized from internal energy of the system. This is the amount of energy utilized for adiabatic expansion. Clear? So in stage 2, process 2, changes in energy of the system is equal to minus 6234 joules, and then Q, that means what is the dW, W or W223 is equal to 6234 joules. This is process 2. And process 3, reversible isothermal compression process. Reversible isothermal compression process. Isothermal means T is equal to constant and changes in temperature is equal to 0. U is equal to constant and changes in internal energy is equal to 0. Hence, energy change during the process 3 is equal to 0. So, del E3 is equal to 0. Okay. This is process 3 to 4. So, T3 is equal to T4 is equal to TL is equal to 310 degree Kelvin, and P3 is equal to 9365.5 Newton per meter square, and P4 is equal to 10 to the power of 5 Newton per meter square. Volume V3 to V4. Now I am going to find the amount of work done or heat exchanged. The first law of thermodynamics says that du is equal to dq minus dw. Since it is isothermal process, du is equal to 0, or dq is equal to dw is equal to pdv, or I can write like this: ql is equal to w4 to 1. I'm sorry, w3 to 4 is equal to n r t ln P3 divided by P4. The answer is equal to QL is equal to W3 to 4 is equal to 1 mole into 8.314 joule per mole degree Kelvin into temperature, that means 310 degree Kelvin into ln P3 value is equal to 9365.5 divided by 10 to the power of 5. The answer is the answer becomes minus 6106 joules. This means this is the amount of work done on the system for isothermal compression. This is the amount of work done on the system for isothermal compression, or this is the amount of work removed from the system to the sink. This is the amount of heat removed from the system to the sink in order to maintain isothermal condition. Clear? Okay, process 3 is over. That means QL is equal to W3 to 4 is equal to minus 6106 joules. Okay, next step. Process 4, step 4 or process 4, reversible adiabatic compression. Adiabatic means changes in heat content. This is constant. Heat content is constant, changes in heat content is equal to 0. Clear? This is process 4 to 1. That means T4 is equal to T3 means this is 310 degree Kelvin, and T1 is equal to 610 degree Kelvin, and P4 is equal to 10 to the power of 5 Newton per meter square, and P1 is equal to 10 to the power of 6 Newton per meter square. Volume V4 to V1. The first of third order says that du is equal to dq minus dw. dq gets cancelled. So dw is equal to minus du, or w 4 to 1 is equal to minus cv into dt, or cv minus cv. Initial temperature is V4, final temperature is T1. So T1 minus T4. In order to eliminate the minus sign, CV into T4 minus T1. CV is nothing but 20.78 joule per mole degree Kelvin into T4 310 minus 610 degree Kelvin. Degree Kelvin gets cancelled. For 1 mole gets cancelled. The answer becomes 6234. 600 what is the fourth code? Minus 6234 joules. That means this is the amount of work done on the system for adiabatic compression. This is the amount of work done on the system for adiabatic compression, or this is minus, that means du, minus du is equal to minus 6234 joules, or du is equal to minus gets cancelled, 6234 joules. This is the amount of energy added to the system as internal energy. This is the amount of heat added to the system as internal energy due to adiabatic compression process. Clear? Okay. Del E4 is equal to 6234 joules, and work 4(1) is equal to 6000 minus 6234 joules. Clear? Each and every step we estimated del E, Q and W. Del E, Q and W in each step was established. Next is determine the net work. Net work W net is equal to W122 plus W223 plus W324 plus W421. So W122 is equal to 11,677.6 joules. W223 is equal to 6,234.0 joules. W324 is equal to minus 6,106.0 joules. W421 is equal to minus 6,234.3 joules. So the work net is equal to, the answer is 5,571.6 joule. This is the net amount of work done by the system in a Carnot cycle. It's a positive quantity, hence this is the amount of work done by the system. Okay. What about the efficiency? Efficiency is nothing but TH minus TL divided by TH, or you can write 1 minus TL divided by TH. That is equal to 1 minus 310 divided by 610. The answer becomes 0.49%. This is the efficiency of this Carnot cycle. Okay, clear? Thank you.